Okay, in this video, we are going to talk about functions and review just the basics, okay? The name of this video is going to be function basics, okay? So the first part of what I want to talk about is I want to describe that any two quantities, and when I say two quantities, I'm mostly talking about our coordinate plane, our x and y, okay? That when you compare two quantities like x and y, if they vary in relation to each other, one is dependent on the other, or they just vary, you call that a relation in mathematics. A function is a special kind of relation where every input, x, has only one output, y. So let's look at this parabola here, okay? It's a narrow little parabola. You can see that for every x, there's only one y. When x is 0, y is -4, okay? When x is 1, y is 0. When x is -1, y is 0. See? Every single x only has one y. So I'm going to call this a function and submit my answer. Yes, it is a function. Now I want you to watch what the graphic is doing. You see how that vertical green line is passing across the graphic of the parabola? So let's go to our next page. You can check if a graph is a function by using the vertical line test. So if you draw a vertical line through the graph and it only touches the graph in one place, for every place you move it, then the graph is a function. Before we go on to the next section of function basics, I want to show you that this is an example of a relation that is not a function. Okay? Look at this. You will see that if you drew vertical lines through this mathematical structure, through this graph, you would see that for every x, there's two y's, right? When x is 1, y wants to be 1, y also wants to be -1. Okay? When x is 7, y wants to be 1, or it wants to be -1. That is not a function, that is a relation. Let's watch and see. Yay! See, watch as we move the vertical line. So there's one more example that I want to show you, and that is a mapping diagram. Mapping diagrams are another super good visual for determining whether a relation is a relation or a function. So let's take a look. Here we have a mapping diagram, okay? You can see we have set A, which are the inputs, and set B, which are the outputs. And you can see that every input knows where it wants to go. It only has one output. 2 goes to 9, -3 maps to -4, and 7 maps to 8. So this mapping diagram represents a function since there is one number for each number in set A where there is only one mapping to set B. See if I did this correct. Oh, I didn't put it in right. I got the right answer, but the fact is that this is a correct mapping. This is a function. I just didn't do the little, I just didn't pick the correct verbiage. So let's look at one more of these. So let's take a look at this. And I'm not going to bother with the verbiage. So we have -3 that wants to be 4. We have 0 that maps to 4. But look, 0 wants to also map to -4. You are not allowed to have this, okay? You can have more than one x mapped to the same number. That is what we call a vertical line, a horizontal line, right? If this is a line up here, and this is like 4, right? This is y equals 4. So we can have 1, 2, 3, blah, blah, blah. They're all mapping to y equals 4. See, all of these could be mapping to 4, but they're not. But this input has more than one output, and that is what cannot be allowed if you're going to have a function.